In this video, we're going to be looking at some polynomial functions and models. I'm going to go over a quick overview of polynomials. So a polynomial has this look right here, where these coefficients a sub n minus 1, a sub n minus 2, and so on are real numbers. We're going to focus on real numbers, but they can be complex or imaginary numbers. And the exponents of these x terms here, n minus 1, n minus 2, and so forth, those are non-negative integers. So this one states, determine which functions are polynomials and state the degree. So the first one, then f of x equal to 5x to the third minus 3x plus 4, does this have this particular look? We have x to the power of 3, x to the power of 1, and we have a constant. Coefficients are real numbers. Now the degree of the polynomial is always the exponent of the highest degree term, which is this one right here. So this one does satisfy this definition. This one is a polynomial, and the degree of this polynomial is 3. Had this been, say, a negative 3, then that would not fit the conditions we just went over. The exponents have to be non-negative integers. Make that a negative 3. It's not a polynomial. The second one, the coefficient is the square root of 3. That's real. It's a radical, but it's real. And the highest degree term, we only have one. That's this one here, has an exponent of 2. So this one is a polynomial, and the degree is 2. Now for C, we have f of x equal to 3 plus x over x minus 3. Well, again, here we have a variable in the denominator, so I can't write this in this particular form here. So this one is not a polynomial. So we don't have a degree for this one. For D, we have f of x equal to the square root of x minus 3. This one we have the x value, x minus 3 in this case, under a radical. Can't get it in this form. So this one is not a polynomial. Also, another thing to keep in mind here, if you have a polynomial and you evaluate the polynomial at some number r and you get 0, then we say that r is a 0 of that polynomial. We can also say that x minus r is a factor of that polynomial, and we can also say that r comma 0, or the point r0, is an x-intercept. The graph crosses the x-axis at the point r0. So that's what you know. Anytime you have a polynomial evaluated at some number r and you get 0, you know that r is a 0. You know that x minus r is a factor. You know that r0 is an x-intercept of that graph. And we're going to use these ideas in the next few problems here. Another thing you want to know about a polynomial in general is that the lead term is always going to determine the behavior of the graph. So if the degree is even, say degree 2, degree 4, degree 6, then the graph goes up at one end and up at the other. Goes like that. And then you could have several loops here or turning points in between here. Also keep in mind that the graph of a polynomial is always continuous. It has no breaks. It'll have several loops. In other words, you could have something like this, no breaks. Different than a rational function like C, that could have some breaks in the graph, vertical or horizontal asymptotes. Now, if the coefficient here is a negative and the degree is even, same sort of thing, except in this case the graph goes down at both ends. Goes down on the left side and down on the right side. If it's positive, of course, it goes like that. Now, if you have an odd degree, this is, say, a 3 or a 5, then the graph goes up at one end and down at the other. The degree is going to determine also how many turning points to expect. So a turning point looks something like this. You have a graph coming down and then it goes up. That's one turning point. Or you could have something like this. Like this, like this, like this. So if the graph goes up and then comes down, that's one turning point. This one's going down and then up, that's another turning point. Up and then down, another turning point. So it has 1, 2, 3 turning points. So the other thing to know for graphs of polynomials, if a polynomial has degree n, then the graph will have at most n minus 1 turning points. So if you look at, say, a polynomial, look at the graph of f of x or y equal to x to the third. Well, if I were to sketch the graph of this by just plugging in points, I get a graph that looks something like this. I get a similar graph if this were a 5, an odd. So this one has degree 3. So based on what I just said, you would expect this graph to have at most 3 minus 1, looking at this right here, turning points. Well, how many turning points does this graph actually have? It's going up, and then it looks like it's coming back down, but no, it continues. So it has 0 turning points. It still fits the condition. If it has degree 3, it can have at most 2 turning points. At most means 2 or less. So that could be 1 or 2, 1 or 0. In this case, it's 0, no turning points. So with that in mind, then, let's look at the next problem. Form a polynomial whose zeros and degree are given. Don't expand. So p of x has these zeros, -2, 0, and 4. So remember, I said if r is a 0, then x minus r is a factor. So I'm going to do the middle one here. 0 is a 0 of the polynomial, so x minus 0 has to be a factor. Well, x minus 0 is x, so that would be one factor. -2 is a 0, so x minus that has to be a factor. That would give me x plus 2. 4 is a 0, so x minus 4 has to be a factor. You got that? And then you could multiply it out, but this one says don't expand, so we just leave it as x plus 2, and x minus 4. That would be the answer to that one. Now for b, we have zeros are, so x minus 2 then, x minus a minus 2 has to be a factor, so x minus a minus 2 would give me x plus 2. And the multiplicity is 3. All that means is this repeats. So I put it through here. It has a 0 of 1, a multiplicity of 1, so that means that factor is only there once, so this will be x minus 1 to the first power. So if I multiplied this out, I'd have an x to the 4th, and that fits because it says degree 4. So that would be the answer to that one. So if they give you the 0, you can find the factor that goes with that, writing x minus that, whatever that 0 is. And if it gives you a multiplicity, just put it as a power. That one checks. We look at the next one. Find a polynomial function that could form the graph below. So I'm going to name this p of x. Now if we look at this right here, this is the point 0, 0 here. It crosses right there, and this is 1, 2, that's at -2. So this one has zeros of -2 from this one here. And it crosses the origin, so another 0 would be 0. And you can see here, it touches the graph, the x-axis at that point right there. That's the point 1, 2, 3. So this would equal 2. Then I can set up an expression here. So if it has a 0 of -2, that would be just x minus a minus 2, so give me x plus 2 here. And then right here is 0. So that would just be x minus 0. It's an x, so I'll put that in front. Be like this. And then it's 1, 2, 3. It crosses right there. So this would be x minus 3. So that concurs with what I have here. But now notice that the graph goes up at both ends. If you have a polynomial and the graph goes up at both ends, the degree has to be even. Now, if the graph goes up at one end, down at the other, and the opposite, then the graph has, or the polynomial has to be odd degree. Now, if I look at this, I got an x here, an x here, an x here. So if I were to multiply this out, the highest degree I'd have here is x to the third. That's odd. It's not going to match with this one. So the thing you have to remember here is that right here, if the graph doesn't cross at a certain point, so notice here at negative 2, 0, it crosses. At 0, it crosses. The powers on those are odd, 1, 1. So this one here, when it touches and doesn't cross, the degree has to be even. So instead of a 1 here, I would have to have a 2. Now it concurs with the information we just went over. Let's look at the next one. It says use transformations of y equal x to the fourth or y equal x to the fifth to graph each function. The y of x to the fourth, the graph of y equal x to the fourth rather, basically has the look of a parabola. Looks like that. The graph of y equal x to the fifth pretty much looks like the graph of y equal x to the third that I went over a while ago. And that graph goes something like this. So let's look at the first one. X plus 3 to the fifth power, we refer to this one. When you have something like x plus 3 or x minus 3, we're going to have a transformation that takes the graph horizontally. So notice if I put a negative 3 right here, that gives me 0. So I'm going to get this kind of graph. If it's x minus 3, it's going to be this same graph right here, except it moves it to the right. If it's x plus 3, it moves it to the left. So this is your graph here. Now when it's just added on the side here, you have a vertical transformation. Moves it up 3 units. Goes something like that. For this one, we use the graph of y equal x to the fourth, which is the look of a parabola. So this one has both of those. This one right here, the minus, moves the graph 1 unit to the right. The minus 2, it's added or subtracted here, moves it up or down. So this one would go 1 to the right and 2 down. And then the graph would go something like this. And just a rough sketch. And for the next one here, sketch the graph of each function by using the end behavior and multiplicity of zeros. So let's look at this one. I got x to the third, and x and x. So if I multiply those out, this will be degree 5, which is odd. And the coefficient would be positive. So I'd expect the graph to go up at one end and down at the other. Without plotting any points. That's what I would expect. So it's going to pass through this point right here, 0, 0. Going to pass through 1, 0. Those are the zeros or the x-intercepts if you want. And then we're going to go 1, 2, 3. Going to pass to that point. And we expect it to look like this. It's going to go up at this end, down at the other end. So let's start from right here. It passes to this point right here. So if I pick a number 2 and put it in there, that's going to come out positives. So the y value is positive, so I know the graph is going up like that. Between 0 and 1, if I pick, say, 1/2, 1/2 there, 1/2 there, I'm going to get a negative, so the graph's going to come down. How far? I'm not sure unless I pick some values, but I'm just going to put it like that. I can do it like that. And then between negative 3 and 0, if I pick a value here, say negative 1, and negative 1 here, negative 1 here. So these two terms will be negative. They cancel each other. I get positive. This is a 2. So this graph is going up. How high? Don't know unless I plug in some values. So this is just a rough sketch. I know it has to come down though, because it has to cross here at this intercept here. So this is going to come down like this. And then I know I have to go down because of what we just said. So this is going to come down this way. And that's a rough sketch of that graph. Now let's look at the next one. X plus 2 is 0 at negative 2. So the zeros for this one, which correspond to the x-intercepts, we'll get negative 2, and then this one is 0 at 2. 2 minus 2 is 0, so this is 2 here. And then I have x plus 4 is 0 at negative 4. So those are the zeros. So let's plot these. So I have 1, 2 there, and then negative 2 over here, and then to 4. So I've got negative 4 here will be 1, 0. Negative 2 will be another 1. And then we have 2 over here. And notice I have a 2 here, an x and an x, so this one has degree 4. The lead term will have degree 4. So I expect the graph to, and it's positive, I expect the graph to go up at both ends. You could have several loops in here, but I know it's going up at the right side and up on the left side. So if we pick a number to the right of 2 here, say 3, I get all positive, which is what I expect. The graph is going to go up. The graph's going like that. If I pick a number between negative 2 and 2, say 0, I get a positive here, a negative here, positive here. So that's going to give me a negative value between 2 and negative 2. So the graph is going to come down. And it stays negative, but it has to go up because I have an intercept here. So it has to touch right there. And if I pick a number between negative 4 and negative 2, I'm going to get a negative value. So I know the graph has to come down. So it's going to go like this. So it's going to touch at negative 2. And then I know it has to go down, but I know I have to eventually go up because I have an intercept at negative 4. So the graph is going to go like that. And I knew that I had to touch there at negative 2 because of the even power at negative 2. Remember, if it has an even power at that particular 0, the graph doesn't cross, it touches. So that's the graph for this one. Thanks for watching. We'll see you next time.